Okay, 5.373. Here's the identity that we're supposed to prove. Okay. Back in 5.3, the only tool we had besides kind of the fundamental identities was the sum formula for cosine, the sum identity, sum and difference identity for cosine. Actually, yeah, just for cosine, in fact. But the problem gives you a hint. It says cosine 2x is the same as cosine x plus x. If you apply that hint and then the sum identity for cosine, what you get is just that cosine 2x is cosine squared x minus sine squared x, right? So that might come in handy. Looking at this, though, I would say the right-hand side is a little nastier than the left-hand side. So I'm going to work with the right-hand side, try to manipulate it a little bit and see if we can get it to look like the left-hand side. So starting with cotangent squared x minus 1 over cotangent squared x plus 1. Well, now what do you do with this, you know? One thing that you could try is you could multiply by, say, the conjugate of the denominator and just kind of see where that gets you. I'm disinclined to do that because then I'm going to end up with a cotangent to the fourth power, and it just seems like at that point things are sort of spiraling out of control a little bit. So I don't think that's the thing to do here. What else could we do? Well, I think of tangents and cotangents, especially sines and cosines. I mean, I'm just thinking of this as cosine over sine, you know? And if this is cosine over sine, it's a fraction. I can think of this as sine over sine, and then, have a common denominator so I can add these up. Looking forward, if I did the same thing in the denominator, I'm going to end up with the same, little denominator inside of my big fraction, you know what I mean? Which will end up canceling off. And I think that will lead me somewhere nice. Let's see. So I'm thinking of this as cosine squared over sine squared. And, a second ago I said get a common denominator, add the fractions. Another way to do the same thing that I think takes fewer steps is to just go ahead and multiply by sine squared x. Right? In the numerator and denominator. Now this will give me, here the sine squared x will cancel. I'll get cosine squared x minus sine squared x over, here the sine squared will cancel. I'll get cosine squared x plus sine squared x. Cosine squared plus sine squared is 1. So of course this is just cosine squared x minus sine squared x. And then a second ago, before I started working this out, this is exactly what we said cosine 2x was equal to, right? And at this point, I mean, you have the benefit of knowing the double angle identities, right? And this is one of them for cosine 2x, right? So this is cosine 2x, and you're done with that one. Again, probably more than one way to do that.